So here we back again, understanding the predict logic. So let's start with over here. 2 is an even number. Okay, so it's clearly a true, right? 2 is an even number. 3 is prime number, right? It's also true. 3 is prime number, is divisible by itself, and 1. So these are fixed statements, right? And it's a proposition, right? So proposition is either true or false. But what about this? X is even. This is not true or false yet, but also not false yet, right? It depends on what X is. So what is X? And for that, predict logics helps. Okay, so we call this type of statements which is like X, where we don't know what X is, so we call this type of statement open statement or predicate predicate. Okay, it becomes a real proposition only after when you fix X. So when we assign the value to the X, or we fix the X with any number, then it's become a real proposition, either true or false. So let's see more here. So what is predicate? Let's very simple. It's just a sentence with a variable. So px, x is a even, x is even. Okay, we don't know yet what is x, but now let's see. If x equal to 4, if x equal to 4, p4, 4 is even, right? An even number is 2, 4. Just adding 2 in the number sequence, 2, 4, 6, 8, like this. So those are all even numbers. So 4 is also even number. But if we check x equal to 5, p 5 is 5 is even. No, 5 is not even. It's false. So predicate formula waiting for a value. Okay, so here x is waiting for the value to assign, right? Here we assign 4, 5. Here it was waiting, so we assign 4 and 5. Okay, so that's why do we need quantifiers? Okay, predict alones are not complete statement. We need to answer this question like this: is it true for every x, or is it true for at least one x? Okay, and to answer these, we use quantifiers to answer this question. Is this true for every x, or is it true for at least one x? Okay, so first start with universal quantifier, and this is the simple, and it simply means for all. Universal for all, meaning for all value of x. So for every value of x, whatever the x have, is it true? Let's see. Symbol, this is universal x, and this is propositional x, and this is we wanna predict means for all x this symbol, for all x here, for all x, and this is px is true, px is true. Okay. So for all x, px, for every number of x, right? See it, for every number of x, 1 2 3 4 5 6. Okay, so x plus 1 is greater than x. This is true, right? So if a x plus 1, so whatever the x here will be greater than x, right? Just like 1 2 3. What is 2? 2 is basically 1 plus 1, 2. What about 3? 3, it's 2 plus this 1. So this is greater than, right? So 3 is uh, 4 is greater than 3, 2 is greater than 1, and 3 is uh, greater than 2, right? So 2 plus 1, 3, right? So if we assign here value, it will be easy. Suppose in here we assign 3 and here we assign 2, so this is true, right? So 3 is greater than 2, right? 3 is big than 2. Okay, let's see. Let me clear the camera. Example 2. Px x is even. Okay, this is an example 2. So for all px means every number is even. Does every number is even? No, right? 2 4 6 8 like this. But what about 3 5 and 7? These are odd numbers, so this is false, right? So that's the thing. Every number, if every number is even, then this will be true, but that's not the true, because there are numbers which are odds. That's why this is false. Yes, let's see another quantifier, which is existential quantifier. So what does this meaning? There is at least one value of x. Okay, there exists one value in all number. There is one value which is exist and it's true. So let's see. This is a symbol of exist. There exists, px means there exists at least one x such that px is true, right? There should one x exist, so does the px is true. Let's see the example. Px x is even. Okay, we yet don't assign, we have not assigned the value in the x right now. We are just assuming, right? We will do this. So exist x, there exists x, px means there exists a number which is even, right? So this is true, right? In numbers there would exist at least one number which is even, but we know that there exist even numbers like 2 4 6, right? So this is true. But if there is, suppose, like, if there are all numbers and of a set like this, what I mean, 3 5 7 and 2 at last. Okay, if you see this number is odd, this number is odd, this number 7 is odd, but this 2 is even. So that's make it true, because although we have a maximum of odd numbers, but this even make it true because there at least one x such that px is true. In existential quantifier, we need at least one x need to be true. Okay, so let's continue with example 2. So px square equal to 3, px square equal to 3 in integer. So let's see of the form symbol existential x. Px means there exists an integer whose square is 3. Okay, so the square can never be 3, right? X square can never be 3. That's why this is false. Now let's all what we learn, and it should be clear now with this small table, we can say. Let's start. So here we have px, the proposition, this, right? And this is predict, this is proposition. We have to predict this x. So x is even, domain integer. So integer just like number, but they also have negative. But for now we are not focusing on negative numbers, we're just focusing on positive numbers. So here statement. Okay, so this just we will go by line, only by one line first. So p4, let's check. P is even. Does p is even? The 4 is even number. So 4 is even number, that's right, so it will be true. Let's check p. We assign the x with 5. His 5 is even number. No, 5 is odd number, so what we did false. Now let's put the symbol over here. Universal x, px, all numbers are even? No, we see that there are also odd numbers, so universal all numbers are not even, so that's why it's false. Does exist, this is exist, there exists a proposition x, at least one even number is, like at least one number is even. Does in all integer number there is a one number which is even? So yeah, answer is true. This is a simple trick for you to remember. Let's say this is the sign, everyone, for all, or we can say for every. So everyone, this is a symbol. This existential symbol, someone, and this proposition we are representing as a property. So universal x, px, everyone has this property. And what about existential, ex, px, and someone has this property. And now let's check if you understand this predict logic or not with this simple statements. Don't see the answer now. Okay, so there exists a student who is absent today. So what is this: there exists a student who is absent today. So this is existential question, right? All triangles have three sides. So this is a universal. If you understand this statement, then you understand the predict quantifiers in that universal quantifier, which is this one, and existential quantifiers.